Hello everyone. Through this series we will be discussing NEET PYQ chapter wise. To start with that, this is the first chapter that we will be discussing, ray optics, and this is the first question that is in front of us. Let's read. So according to the description that is given in the question, an object is placed at a distance of 40 cm from a concave mirror whose focal length is 15 cm. And then it goes on to say that if this object is displaced through a distance of 20 centimeter towards the mirror, then what is the displacement of the image? First of all, if the object is displaced towards the mirror, image will be displaced away from the mirror. Therefore, option number 3 and option number 4 cannot be the answer. Now let's find the value. If I were to describe the situation, it is like this. This is the concave mirror. This is the focal point, which is at a distance of 15 centimeter. This is the center of curvature, or twice f, which is 30 centimeter. And this is the initial position of the object, which is 40 centimeter. Corresponding to this initial position, the initial image position will be, let's say, this one. So if I write down that initial position of the object is minus 40, minus sign is because of the sign convention. Corresponding to that, the object position will be something, let's say, v1. Now what we do is that according to the question, the object is shifted towards the mirror by a distance of 20 centimeter. Okay, so we have shifted it by 20 centimeter. Now from the mirror, the distance of the object would be 20 centimeter, and the image of this corresponding object will be going outside. Okay, so corresponding to the new position of the object, which is 20 centimeter, let's say the image position is v2. Therefore, the displacement of this image will be this much, which is nothing but v2 minus v1. This is the quantity that we have to calculate. So for both the cases, let us calculate one by one. So first, for the first case, when the object was at 40 centimeter distance, if I apply the mirror equation, it will be like this. So the position of the image will be 1 by f minus 1 by u1. By applying proper sign convention, this will be equal to minus minus plus. This will be 40, 15 into 40. This is minus 40 plus 15 minus 25. This is 5, 8, 5, 3. This will be equal to 1 by minus 1 by 24. So the initial position of the image is minus 24 centimeter. Now let's calculate the final position of the image. When the object is at a distance of 20 centimeter, at that time we will apply the mirror equation, and the mirror equation gives something like this. Again, we will put the value with proper sign convention. So this will be equal to 60 minus 4 plus 3. This will be minus 1. So it will give me that v2 equal to minus 60. Therefore, the displacement of the image will be minus 60 minus 24, which is equal to minus 36 centimeter. Minus means it is going in the minus x direction according to NC sign convention. So this is option B. Let's move on. One more thing before we move on. If we focus at the relationship between or plot between the variation between the image position and the object position for concave mirror beyond the focal length, the graph looks like this. This is my focal point. So we see that if we shift the object position a little bit, then the image will be shifted by a large amount. At least compared to object distance, the shift in the image distance will be more. And here in this problem also we see that the object is displaced by 20 centimeter. On the other hand, as a result of this, the image is shifted by 36 centimeter. So shift in the image will be more up to focal length. The variation is in the third quadrant. Okay, let's move on. This is the next question. This question is based on the plane mirror. So the question is as follows. A beam of light from a source L incidents normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back as a spot on the scale placed just above the scale, above the source L. When this mirror is rotated through a small angle theta, the spot of the light found to move through a distance y on the scale. What is the value of this angle? So if I were to draw the diagram, let's say this is the mirror, okay? This is the plane mirror, and initially let's say this is the source, the given source, and the given source is actually along a scale. This is the source L, and this source is along a scale, and this source is at a distance of x, perpendicular distance x, and initially this ray of light falls on the mirror perpendicularly. What does it mean? Angle of reflection, angle of reflection and angle of incident both are 0. It goes to the same spot. But according to the question, when we rotate this mirror by a very small angle, right, when we rotate the mirror by a very small angle, then the normal of this particular mirror will also be shifted by a very small angle. Actually it would be like this. Let me use the eraser. So this will be the normal. Now the ray of light will fall at an angle of theta only because the normal has shifted by an angle theta, and the reflected light will move along this direction and it will strike on the scale on this particular spot, and this angle is also equal to theta, and this distance is given to be y. The new spot and the source, this distance is given to be y. Now the question is, what is the value of theta? And the given condition is that the angle theta is very small. So if I write down the tan of twice theta, why 2 theta? This angle is 2 theta. It will be equal to perpendicular by base. So for small angle, tan theta equal to theta. So it is 2 theta will be equal to y by x. Theta will be equal to y divided by 2x. So option 4 is the answer. Let's move on. We are given another plane mirror question. Let's read the question. According to the description given in the question, there are two plane mirrors which are inclined at an angle 70 degree with each other. So let me draw this. This is one mirror, and let's say this is another mirror, and the angle between them is 70 degree according to the question. Now let's read the question further. A ray incident on one mirror at an angle theta after reflection falls on the second mirror and is reflected from there parallel to the first mirror. The value of theta is equal to what? Well, so let's say this is the incident ray. It falls on the first mirror at an angle theta. Therefore, it will reflect at an angle theta, and then after reflection from the second mirror, it goes parallel to the first mirror. That's the condition. So since this ray of light, the final direction of the ray of light is parallel to the first mirror, therefore if this angle is theta, from geometry this angle will be theta. Now if I draw normal on this point of reflection, this angle will be also 70. So 70, 70, 70. Well, in this triangle, this angle 70, this angle 70, 140. Therefore this angle will be 180 minus 140. So this will be 180 minus 140, that will be equal to 40. Therefore this angle theta will be equal to 90 minus 40, which is equal to 50. So answer is option D. I hope this is clear. Let's move on. I request you all, you attempt the questions by pausing the video by your own. Please go through the solution only after you are done with the problem. That is the effective way to solve the problem. Anyway, a rod of length 10 cm lies along the principal axis of a concave mirror whose focal length is 10 cm. in such a way that its end closer to the pole of the mirror, I mean, is 20 centimeter away from the mirror, and the length of the image is something that we have to find. So if I were to describe the situation, it is like this. Let us consider this is the concave mirror, and let's say this position is focal point, this position is the center of curvature. This distance is given to be 10 centimeter focal distance. Center of curvature would be equal to 20 centimeter. Okay, and if I were to draw the rod is placed in such a way that one end of the rod is at a distance 20 centimeter away from the mirror. Let's say this is one end, this is another end. The twice if, or the center of curvature, is 20 centimeter, and one end of the rod is also 20 centimeter from the mirror. Well, now you see, we have to find the length of this image, right? To find the length of the image, we will consider this, both the ends, I mean the end A and end B of the rod, to be different objects. Let's say for first end A, what is the object distance? It is minus 20. Okay, it is at a distance 20 centimeter from the mirror, and the length of the rod is 10. What does it mean? It means the other end is at a distance of 30 centimeter. Now whenever object is placed at a distance of equal to twice f, or whenever object is placed at center of curvature, the image will be formed at center of curvature. So image of this will be at the center of curvature only. Now where will be the image of this B? That is something that we have to find. So the image corresponding to this end A is nothing but minus 20 centimeter. Image corresponding to end B is something that we have to find, and after that the length of this image will be equal to the difference of the position. That's the thing that we have to find. So let us apply the mirror equation. So 1 by f minus 1 by ub, applying proper sign convention, this is minus 10, and this will be equal to minus minus plus 30. So this will be equal to minus 30, 3 minus 2, so this will be equal to minus 1 by 15, or this is equal to minus 15. So what is the length of this image? Length of the image would be equal to minus 15 minus minus 20 equal to 5 centimeter. That's the answer. Let's move on. Okay, let's read this question. This question tells that a ray of light falls on a glass surface whose refractive index is square root of 3 at an angle 60 degree with it. The angle between refracted and the reflected rays will be what? So if I were to describe the situation, let's say this is one medium, denser medium, which is nothing but the glass, and I consider that the other medium from where the ray of light is coming is vacuum or air, so that refractive index is 1 there, and refractive index here, it is square root of 3. The ray of light strikes here at what angle? At an angle 60 degree. So this angle is 60 degree, and then a portion of the ray of light is reflected and another portion is refracted. Okay, this ray of light will actually bend towards the normal, so in this diagram I cannot maintain that anyway. So this angle will be nothing but 60. Let's say this angle is R. Now we have to find this particular angle, the angle between reflected ray and the refracted ray. So what is this angle? This angle is equal to 90 minus 60 is 30, and this angle is something that we should know, which is 90 minus R. Okay, well, if you observe carefully, we can solve this problem without doing this much, without using Snell's law at all, but I will tell that after giving the proper solution of through Snell's law. Anyway, first of all, you see, we will apply the Snell's law on this interface. So n1 multiplied by sine of 60 equal to n2 multiplied by sine of r. So sine of 60, this is 1, equal to square root of 3 into sine of r. This is square root of 3 by 2 equal to square root of 3 into sine of r. So sine of r will be equal to 1 by root 2 and r will be equal to 30 degree. What does it tell? It tells that this angle is 60 degree. So what is the angle between reflected and refracted rays? This is equal to 30 plus 16, nothing but 90. Now you observe one thing. We can solve it like this by drawing the diagram and so on. But observe one thing, that in polarization topic we know that at the polarization angle, when the ray of light incidents on the interface at polarization angle, that time the angle between reflected ray and refracted ray, they are 90 degree with each other. And Brewster's law tells that the tan of polarization angle is equal to mu. Now you see in this particular problem, the theta is 60 and it comes out to be square root of 3. And the refractive index is also given to be square root of 3. That means in this condition, the ray will be plane polarized and the angle between reflected and refracted ray will be 90 degrees. So without doing so much, we can get the answer very quickly. Let's move on. Okay. So let's read the question. So according to the description given in the question, change the color. We have one air bubble and this air bubble is inside a glass slab. Okay, an air bubble is inside a glass slab with refractive index 1.5. That means the refractive index of this glass slab is 1.5 and near normal incidence, this glass bubble is 5 centimeter deep when viewed from one surface and 3 centimeter deep when viewed from the other surface. The question is, what is the thickness of the slab? First of all, let us consider this is the air bubble. Okay, now when I observe this air bubble from this side, then I will see the air bubble some distance near to the observer or me. Okay, this is the apparent distance and this distance is given to be 5 centimeter from one side. On the other hand, when I look the object from other side, the air bubble, let's say it is here and this distance is given to be equal to 3 centimeter. This 5 centimeter and 3 centimeter are nothing but the apparent distances of the air bubble. Well, then what is the real distance? Real distance will be, let's say this is d2. From this side the real distance is d1. Now you see, what is the thickness of this glass slab? Thickness of the glass slab will be d1 plus d2. That's the thickness which we have to find. Okay, let me apply the formula directly. The outside medium, as we consider nothing is given, it is equal to 1 air. So refractive index of the medium of the glass slab is equal to real distance divided by the apparent distance. So the real distance would be equal to n multiplied by the apparent distance. So 1.5 into 5. So this is equal to 7.5 centimeter. From other side, the refractive index is real distance divided by the apparent distance. So real distance will be equal to n multiplied by the apparent distance, 1.5 into 3, which is equal to 4.5. So when I take the sum, this will give me 12 centimeter. Okay, let's move on. Okay, according to this question, a beam of light composed of red color and green ray is incident obliquely at a point on the face of a rectangular glass slab. When coming out on the opposite parallel face of rectangular glass slab, which means the red color and green color will emerge. Okay, and some statements are given. So basically it wants to tell something that the green color and red color would be separated. Okay, now before we attempt this question, focus on one thing, that the refractive index, it depends on the color. So refractive index is basically inversely proportional to the wavelength of the color. So if the wavelength is more, refractive index will be less. Okay, now let us describe this situation. Let's say this is my glass slab. Okay, this is the beam. This beam contains red color and green color both. After this refraction, the colors green color and red color both will be separated. Why they will be separated? Because on this interface the rays of light will bend according to Snell's law. Snell's law gives the refractive index of the medium, which depends on the wavelength of the light. Okay, but angle of incident for both the colors will be same. Now you see, we already know that for parallel glass slab or parallel interfaces, after the ray of light comes out, the emergent ray is parallel to the incident ray. Okay, so one thing is clear, that both the rays, they will be parallel to the original direction and parallel to each other also. Okay, they will be parallel to each other, so they cannot go in non-parallel direction. Okay, acha, will they split? Yes, they will split. Why they will split? Because when I write down the Snell's law, sin I by sin R equal to refractive index of the medium. Okay, this refractive index of the medium is different. Okay, this refractive index of the medium is different because colors are different. I have to write the Snell's law for both the colors. Now angle of incident for both the colors are same, which means if they are having the different refractive index, the angle of refraction has to be different. So for red color, this refractive index will be less than the green color because the wavelength is more. So for red color, this will be less, which means this R will be more. So this will be my red. Okay, and this will be my green. This angle will be red, and this angle of refraction will be for green. So since the angle of refractions are different, they will emerge out from two different points, but they will go parallelly. Why? Because both the interfaces are parallel to each other. So option B is the correct one. Let's move on. Okay, recent question. According to the question, a light travels the distance x in time t1 in air, 10x in time t2 in another denser medium. What is the critical angle of this medium? Okay, first of all, understand one thing. The critical angle is a concept which appears in the total internal reflection. What's a total internal reflection? You see, when ray of light goes from denser medium to the rarer medium, then it bends away from the normal, right? Therefore, sometimes it overbends towards the normal, away from the normal. Let's say this is the angle of incident. So if it happens that the angle of incident is less than some critical value, then the ray of light will suffer refraction, which means it will transmit into another medium. It will transmit into another medium, the rarer medium. On the other hand, if the angle of incident is more than the critical angle, then it will reflect back into the medium. This is called total internal reflection. What is this critical angle? This critical angle is an angle where angle of incident, for this corresponding angle of incident, the ray of light will go parallel along the interface. So at that condition, the angle of refraction is taken to be 90 degree. The critical angle's value is, normally we write it like this. By applying the Snell's law, sine of R is 90. So this is equal to N1 divided by N2. Remember one thing, this N2 is the refractive index of the denser medium and N1 is the refractive index of the rarer medium. Normally the rarer medium is taken to be 1 if it is not mentioned. Here it is not the case. Okay, fine. So basically in this question we have to find the critical angle, which means this one. To find the critical angle we need the refractive indexes, which are not given. However, the refractive indexes are inversely proportional to the velocity. Let's say velocity here it is v2, velocity here it is v1. So through velocity we can find out the critical angle. Well, velocity I can write down the distance divided by time, distance divided by time, and thereby we get the critical angle to be sine inverse of tan t1 by tan t2. Option B is the correct one. So let's move on. Okay. So here in this question, there are two transparent media, A and B, separated by a plane boundary. The speed of light in the medium are given 1.5 into 10 power 8 and 2 into 10 power 8 meter per second respectively. And we have to find the critical angle for the ray of light. Critical angle, again, ray of light travels from denser medium to rarer medium, total internal reflection. Well, so let's say this is n2, velocity v2, refractive index n1, velocity v1. Now this medium is denser medium. What does it mean? It means the velocity or the speed of light in the denser medium is less. So this is 1.5 into 10 power 8 and this is 2 into 10 power 8, and I have to find the critical angle. So critical angles formula is what? This is equal to n1 by n2. Refractive index of rarer medium divided by refractive index of the denser medium. In the denominator we have to write down the refractive index of the denser medium. So this is equal to velocity of denser medium by velocity of rarer medium. So this is equal to 1.5 into 10 power 8 divided by 2 into 10 power 8. So sine of IC would be equal to 1.5 means 3 by 2 and this is 2. So this is 3 by 4 which is equal to 0.750. Therefore this I will be equal to sine inverse of 0.750. Option B. So let's move on. I hope this is clear. Okay. Let's read the question. So here in this question it is given that a ray of light traveling in the transparent medium whose refractive index is mu, it falls on a surface separating the medium from the air at an angle of 45 degree. For which of the following value of mu the ray can undergo the total internal reflection? So let's say this is the denser medium and this is the air or the rarer medium, right? According to the question. So ray of light travels through the denser medium, it strikes the interface, okay, and the angle of incident is given 45 degree. And the question is, for what value of mu it will suffer the total internal reflection. Okay, to suffer the total internal reflection, this angle has to be more than the critical angle, okay. Well, what is critical angle? Critical angle is this one. In this case, this n1 is equal to 1 and this n2 is equal to mu, right? Fine. We hold it for a moment. What is sine of 45 degree? In this case, the angle of incident is 45 degree. Sine of 45 degree is 1 by root 2, right? Okay. Now you see, this angle of incident is 45 degrees. To suffer the total internal reflection, this angle has to be more than IC, okay. If this angle is more than IC, right, if this angle is more than IC, what does it mean? If this angle is more, this value has to be what? This value has to be less. Or in other case, you see, if I consider this to be IC, right, if the angle of incident or the critical angle is more, then the refractive index is less. Refractive index has to be less, right? Now you see, critical angle should be less than 45. So critical angle should be less than 45, okay, which means the refractive index should be more than the corresponding value of the 45. So in this case, the mu comes out to be 1.412, okay. So critical angle should be less than 45. What does it mean? Mu should be more than square root of 2. Mu should be more than square root of 2. What does it mean? It should be more than 1.5. It should be more than 1.412. And the only value which satisfies this is this one, okay. I hope this is clear. Let's move on. Okay, let's read the question. So according to this question, a small coin is resting on the bottom of a beaker filled with a liquid. A travels ray of light from the coin travels up to the surface of the liquid and moves along the surface. How fast is the light traveling in the liquid? Okay, so basically we have to find the speed. Okay, now you see from this particular object the ray of light is moving, and after that the ray of light is basically moving along the surface. It means this angle is nothing but the critical angle. If the angle of incident is little more than that, then it will suffer total internal reflection, or if it is less than that, it will transmit into the other medium. Okay, let's say the refractive index of this liquid is N2 and the velocity is V2. The outside medium, it is not mentioned. I will consider it to be air. Refractive index is 1. Velocity is equal to 3 into 10 power 8 meter per second. Okay. Now, what is critical angle? Critical angle is sine of IC should be equal to N1 divided by N2 or V2 divided by V1. Okay. Now, this V2 is something that we have to find, and V1 is given. Now, how to find this sine of IC? IC not given. However, the arms are given. These distances are given. Now, from geometry, if this angle is IC, this angle will be definitely IC again. And this is a 90-degree triangle, right? And we see this arm is 4, this arm is 3. This triangle is also called the lazy physicist angle and triangle anyway. So the hypotenuse will be equal to 5. So sine of this angle will be equal to perpendicular by hypotenuse. So V2 would be equal to 9 divided by 5 into 10 power 8. So 1.4 divided by 5 is 0.8. So 1.8 into 10 power 8 meter per second. So this is option D. I hope this is clear. Let's move on. Okay. Look at this question. This question tells that according to this diagram, what should be the value of refractive index of this glass slab, so that this is a written prism. Anyway, refractive index of the material of this material, so that the ray of light will suffer the total internal reflection. This is written I think prism. I have taken the question from the PYQ book only. So I am there only it is written like this. Definitely it's a printing mistake. Anyway, so refractive index of the material is something that we have to find. Anyway, so this refractive index is, let's say, N2, which we have to find, and outside medium is not mentioned. We will consider this to be air, which is equal to 1. Okay. Now you see, the question is, what should be the value of this refractive index of this material? Okay, let's say that is equal to mu, so that it will suffer the total internal reflection. So we have to consider the critical value. For critical value, this angle has to be equal to IC. Let's say this angle is R. Okay, and this angle is the critical angle. Okay, for critical angle, light won't go along this direction. Remember, it will go along this direction. Okay, anyway, so this is the condition for total internal reflection. So if I draw or drop a perpendicular, this R will be equal to 90 minus IC. Now, first I will apply the Snell's law on this interface. So what it will give me? Sine of 45 degree divided by sine of R is equal to refractive index, or simply mu. Okay, so sine 45 degree is 1 by square root of 2. And what is sine of R? This sine of R is nothing but 90 minus IC. Okay, it is equal to mu. So 1 by root 2, this is cos of IC, it is equal to mu, or 1 by mu is equal to square root of 2 cos of IC. Mark it equation 1. Now let me write down the value of the critical angle. So critical angle sine of IC equal to what? 1 by mu. Okay, so 1 by mu, if I compare from both equation 1 and equation 2, what it will give me? It will give me sine of IC to be equal to square root of 2 cos of IC. Therefore, tan of IC would be equal to square root of 2, or simply tan square of IC equal to 2. Now I have to find the value of mu, right? To find the value of mu, I need the value of IC, or I need the value of sine of IC or cos of IC. Okay, but I have only 10 IC's value, right? So it is nothing. I have to just convert it into sine IC or cos IC, anything. Well, so from 10 square is given, so this is a sec square of IC will be equal to what? 10 square plus 1, right? 10 square plus 1 is sec square. So this will be equal to 2 plus 1, which is equal to 3. Okay, which is equal to 3. What does it mean? It means that cos square of IC would be equal to 1 by 3. Okay, what does it mean? Cos of IC is equal to 1 by square root of 3. Okay, this is the value of cos of square root of IC. So if I put it in the equation number 1, so in equation number 1, what it will give me? It will give me square root of 2 and multiplied by square root of 3. What does it tell? The refractive index is square root of 3 by 2. Option C is the answer. Okay, let's move on. Okay, let's read the question. A disk is placed on the surface of a pond which has refractive index 5 by 3. After that, let me put a full stop. A source of light is placed 4 centimeter below the source of light, so below the surface of liquid. The minimum radius of the disk needed so that the light is not coming out. Now you see, if the light is not coming out, definitely there will be one reflection, total internal reflection maybe. Let's say this is my pond. Okay, this is my pond. Okay, and let's say this is the disk. This is the disk. Okay, and this is the radius of the disk. The radius of the disk is, let's say, r. And this is pond. Outside is air, right? Outside is air. Air means n equal to 1. This is the pond. Okay, whose refractive index is 5 by 3. Okay, and at a distance of 4 meter below the surface, there is a source. We consider this is a converging source, divergent source. The ray of light will go in all possible direction. Let's say this is the one of the ray which touches the edge. Now if it does not go, then it will suffer the reflection, total internal reflection. For that, we need to find this angle. This angle and this angle both are same, right? Now what is the value of this angle? First of all, the critical angle will be equal to n1 divided by n2. So this n1 divided by n2 is equal to 1 divided by 5 by 3. So this sine of IC, if I were to find, I'll keep it as it is. Sine of IC is equal to 3 by 5. So from this triangle we see that this is r, this is 4, right? And this is 5. This hypotenuse is 5 because sine of some angle is perpendicular divided by hypotenuse. Therefore this r is nothing but 3. So this is 3. Okay, see you in the next video. Thank you.